Hi, welcome to the next homework video. So for 6.4, let's look at number 1. So let x be a discrete random variable with probability function f of x given by f of 3 equals 1/3 and f of 9 is equal to 2/3. Find e of x squared minus 2x plus 1. By first finding e of x and e of x squared and then applying theorem 6.4. So e of x squared minus 2x plus 1 is equal to e of x squared minus 2 times e of x plus e of 1. Okay, so theorem 6.4 look back in the book. Theorem Okay, so theorem 6.4 says e of a naught plus a1x plus dot 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 plus a sub n x to the n is equal to a naught plus a1 e of x plus dot 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 plus a sub n e of x to the n. Okay, so that is theorem 6.4. Okay, so that's theorem 6.4, and so we apply it here, and you get e of x squared minus 2x plus 1 is equal to e of x squared minus 2 times e of x plus e of 1. Now we know that e of a constant is equal to that same constant. Okay, so e of 1 here is just 1, so that's plus 1. So if we find e of x squared and e of x, and we plug that in, we can find the answer to this. So e of x is just the sum over x of x times f of x. And so this is 3, so here's 3 times f of 3, which is 1/3, plus 9 times f of 9, which is 2/3. And so that's equal to 1 plus 6, which is 7. So e of x is 7. So this is equal to 7 minus 2 times e of x, which I'm going to plug in there, plus 1. Oh no, e of x is 7, sorry. So this is, I'm going to plug something in here. This I'm going to put 7 in there for e of x. And e of x squared, I'm going to find here. E of x squared is the sum over all the values of x squared, f of x. And that's equal to 3 squared times f of 3, which is 1/3, plus 9 squared times f of 9, which is 2/3. And so that's equal to 9 times 1/3, which is 3. 3 plus 81 times 2/3, which is 27 times 2, which is 54. 3 plus 54 is 57. So e of x squared is equal to 57, right? 81 divided by 3 is 27. 27 times 2, 54. 3 plus 54, 57. Okay, so you plug in 57 for e of x squared. You plug in 7 for e of x. So 57 minus 2 times 7 plus 1, and that's equal to 57 minus 14, which is 43, plus 1, which is 44. And so the answer is 44. E of x squared minus 2x plus 1 is 44. Okay, and so that's number 1. Okay, so let's go to the next problem. Okay, number 2 in the same section. They tell you that the first, second, and third moments, meaning the first moment is e of x, which is -1. The second moment is e of x squared, which is 3. And the third moment, e of x cubed, which is 5. Okay, so it says find e of 4 minus 2x plus 3x squared plus 6x cubed. So what's that? It's e of 4 minus 2 times e of x plus 3 times e of x squared plus 6 times e of x cubed. Okay, And so e of 4 is just 4 minus 2 times e of x, which is -1, plus 3 times e of x squared, which is 3, plus 6 times e of x cubed, which is 5. This is equal to 4 plus 2 plus 9 plus 30. And so that's equal to 45. Okay, so e of that is 45. Okay, so that's 6.4. Those are two problems in 6.4. Okay, so let's jump to 6.6. Okay, so in 6.6, number 1. Okay, so for number 1, 6.6, let x be in a random variable with e of x is 1. And e of x times x minus 1. E of x times x minus 1 is 4. It says find the variance of x and the variance of 2 minus 3x. Okay, so the variance of x, right, is e of x squared minus e squared of x, or just e squared of x is e of x in parentheses, and that's squared. So we're going to find that. So let's look at this equation. E of x times x minus 1 is, e of x times x minus 1 is 4. That means that e of x squared minus x, distributing x times x minus 1 is x squared minus x. So e of x squared minus x is 4. What that means is that e of x squared minus e of x is 4. And so this thing, e of x squared minus e of x squared, that's e of x squared minus e of x minus e squared of x. But okay, wait, let me solve for e of x squared here. So this means that e of x squared is equal to 4 plus e of x. So I can substitute e of x squared for 4 plus e of x. So if e of x squared here is 4 plus e of x, and I'm going to subtract e squared of x. Well, I have e of x is 1. So that's just 4 plus 1 minus 1 squared. And so this is 5 minus 1 is 4. So the answer is 4. The variance of x is 4. Okay, and what is the variance of 2 minus 3x? So the variance of 2 minus 3x is, so first you look at theorem 6.6 in the book. And theorem 6.6 says that the variance of ax plus b is equal to a squared times the variance of x. And so the variance of 2 minus 3x is the variance of negative 3x plus 2. And so here the a is the negative 3, right? The a here's, the a is the negative 3. So this is equal to negative 3 in parentheses squared times the variance of x, which we found. The variance of x is 4. So this is negative 3 squared, which is 9, times the variance of x, which is 4. So that's 36. And so the variance of 2 minus 3x is 36. And so that's the answer to number 1 in section 6.6. Okay. Okay, let's keep going. Okay, so now 6.7. Okay, so 6.7 is on Chebyshev's inequality. And so for 6.7, it says use Chebyshev's inequality to estimate the probability that in any one day the first business of exercise 3 of section 6.5 will make either less than $60 or more than $140 in profit. Estimate the probability of the same event for the second business. So if you look at, so I put that in, there. And so for exercise 3, section 6.5, so the first business, so for the first business, we have that mu, the mean is 100. and the standard deviation, sigma, is $28.87. Okay, so that's the first business. And so Chebyshev's inequality, and actually I'll write the second business. Okay, so the second business, mu is 100, and the standard deviation, and then the standard deviation sigma is equal to $51.96. Okay. Okay. So use Chebyshev's inequality to estimate the probability that in any one day each business will make either less than $60 or more than $140 in profit. So the probability by Chebyshev's inequality that the absolute value of x minus mu is greater than or equal to d is less than or equal to sigma squared over d squared. Okay, well here mu is 100, and so the probability, so what we want is the probability that x is either less than 60 or x is greater than 140. That's equal to the probability that the absolute value of x minus 100 is greater than or equal to 40. How do I see that? Well, if you look at the number line and you look at 60 and then you look at 140, the probability that x is either less than 60 or greater than 140, that's the same that if you look at the middle point, which is 100, that the distance from x to 100 is at least 40, right? So from the midpoint here to here, it's 40. And the distance from 100 to 140 is 40. So if saying that x is less than 60 or that x is greater than 140 is the same as saying the absolute value of x minus 100 is at least 40. Greater than or equal to 40. And so by Chebyshev's inequality, this is a less than or equal to sigma squared over d squared. Well, that's equal to 28.87 squared divided by d squared. D is the 40 here, divided by 40 squared. Okay? And so the estimate is that probability is that amount. Okay? And you just do the same thing for the second business. So this is for the first business. Okay, so that's for the first business. And then for the second business, I'm just going to do the same thing here. For the second business, the probability that x is less than 60 or x is greater than 100 is equal to the probability that the absolute value of x minus 100 is greater or equal to 40. And that's less than or equal to the mu is still 100, which is the same as the first business, but now sigma is different. Now it's less than or equal to 51.96 squared, sigma squared, divided by d squared, which is still 40, divided by 40 squared. And you get that as the estimate. The probability is about 51.96 squared divided by 40 squared. And you put in the calculator and you get the number. And so you just use Chebyshev's inequality. That's the corollary of theorem 6.7. Okay, 6.7 is Chebyshev's inequality, but the corollary to it, you get the equation you need here, the inequality here. Okay, and so that's 6.7, number 1. This is number 1. Okay, okay, let's go to 6.8. Okay, so for 6.8, number 1, so for number 1, 6.8, what is the expected number of 6s and 30 rolls of a balanced die? What is the standard deviation? Right, so the expected value here is n times p, which is equal to n, which is 30, there's 30 rolls, times the probability of a 6, which is 1/6, so 30 times 1/6 is 5. And so, so that's the expected value, right? Sorry, I'm not answering quick. So the expected value is 5. Oh no, it says what is the expected number of 6s? It's 5. Good, that's the expected number of 6s. What is the standard deviation? Well, the standard deviation is just NPQ. Okay, so if you look at the table in on page 213, no, so no table, forget that, sorry. But this is a binomial distribution. Okay, so for a binomial distribution, the expected value is NP, and the standard deviation, the variance is NPQ. Okay, you can compute the variance without the formulas, but it speeds it up. So hold on, let me fix it. So the variance is NPQ. This is for a binomial distribution, which this is because, you just use that binomial distribution. So you have the expected value here, which is NP, which is 5. It's just the number of rolls times the probability of a 6, which is 1/6. So this you expect 5 6s in 30 rolls. And the variance, so the variance is NPQ. So the variance of X is NPQ, which is 30 times 1/6 times 5/6. Q is the probability of failure. P is the probability of getting a 6, 1/6. Probability of failure is 5/6. So this is 5 times 5/6. This is 25/6. So that's the variance of X, and the standard, and so the question is find 6.8, number 1. What is the standard deviation? So the standard deviation, is just the square roots of the variance. So so it's just the square root of the variance of X. And so the square root of 25/6 is 5 over the square root of 6, which is 5√6/6. In simplified form, and you put that in your calculator. Okay, and so that's the standard deviation for number 1. Okay, so that's number 1. Okay, and for number 2, very quickly, it says, suppose the probability of a certain football team wins a game is 0.7. If the team plays 15 games, what is the expected wins? So the expected wins is, again, NP, where N is the number of games, which is 15 games, times the probability of a win, which is, let's say, is 0.7. So 15 times 0.7 is 10.5. And that is the expected number of wins, right? 15 times 7 is 105. You move decimal point 1 place to the left, so you get 10.5. Okay, so that's 10.5. So we'll stop there, and I'll see you next time.